program, we'll explain the various types of processing machines used to make the wide range of plastic products in use throughout our lives. A good start is injection molding. Injection molding is used to make plastic parts using two-part molds that, when closed, are injected with melted plastic to form individual parts. Here's how it works. Material gravity flows into the injection machine's screw, where it is melted by the compressing motion of the screw and then injected into the mold to form the part or parts. The mold is quickly cooled, letting the parts solidify. The mold opens to release the parts, and the mold closes again to repeat the cycle over and over again. Molding cycles can last anywhere from 1 second for tiny parts made in tiny molding machines to minutes for large parts made in presses the size of a building. Extrusion processes use the same plastic melting operation as injection molding, but there is no mold, and the resin compressing screw rotates constantly, and product is created continuously. Extrusion uses a die, a hollow form that molten plastic is pushed through to create its specific shape and thickness. A water bath or spray chamber then cool the extruded shape and often provide pressure and/or vacuum controls to properly size the product as it passes through. Belts or cleated pullers apply smooth tension on the product and keep it moving in pace with the extruder. A cutter or saw create the final product length, or a winder creates spools of the final product. There are many variations to the extrusion process, but a mixture of extrusion and molding is found in the blow molding process, where plastic is continuously extruded into a tube shape and then clamped in a mold and blown into its shape with compressed air. It's a process that often operates in a shuttle movement with a set of molds. Each mold takes a turn grabbing a section of extruded tube, called a parison, and shuttling it to one side to blow it into a bottle shape, letting it cool and then releasing it to be filled with product or shipped. Each mold alternates with a second mold doing the same thing for maximum productivity. The same blow molding process can also utilize multiple extruders for what is called co-extrusion. Co-extrusion is used to create bottles made up of multiple layers, and each layer possesses special characteristics like suitability for food contact, an outside color for brand awareness, ultraviolet light protection for long shelf life of the product, a layer of regrind for economical reuse of scrap, and many times barrier and adhesive layers are included to separate and bond the layers for a tough, cohesive bottle. A high volume form of blow molding uses many molds mounted onto a continuously rotating wheel mechanism. The extruder creates a hollow tube, and as the wheel rotates, each of its molds will open, grab a parison from the extruder die, blow the parison into a bottle, allow it to cool, and then place it onto a conveyor, producing a continuous stream of finished bottles originating from that continuous flow of plastic from the extruder. These wheel machines can also produce co-extruded bottles containing layers designed to meet the needs of the product and to use reclaimed material for maximum economy and recycling benefits. The very popular sales of plastic bottles for carbonated beverages has created a unique process for blow molded bottles made specifically from polyethylene terephthalate, or PET. For PET blow molding, bottles are first created in a test tube shaped, injection molded preform, and then, in a separate operation, reheated and blown into their final shape. This two-stage process creates bottles that we, as consumers, know to be thin-walled, yet capable of containing gaseous carbonated beverages without losing pressure or exploding, even if they are dropped. In the blown film extrusion process, thin plastic material for products like garbage bags or the sheeting used in construction, industry, and packaging are produced. A very thin die opening, which is often fed by multiple extruders, faces upward in a round shape. A tall, thin, continuous bubble is produced vertically by this process, and it's cooled as it flows upward, typically 30 feet or more, where it is then folded and brought back down and placed onto rolls or converted into popular film products. And all these processes, from injection molding to film extrusion, rely on Conair products to support their productivity and efficiency. Thanks for watching.